Okay, so we thus far when we've looked at holes in some of our sample parts, we have looked at exclusively through holes, with the one exception being a block that had a counter bore in the back side of it. And we didn't explain what a counter bore is. Many of you already know, but depending on the background you're coming from, maybe you haven't been exposed to that term. So today what we're going to do is we're going to describe three common hole features. Okay, now all these hole features are typically encountered when you are fastening objects together with screws. Okay, so in assemblies, which we will get into a little bit later, when you see items fastened together, these are common hole features that you will encounter. Now, the first thing you're going to see here is that there are some symbols. Okay, and these symbols represent what is common practice today. We will discuss at the end of this video the callouts that you might see on drawings that are older. So we're going to look at one hole at a time. We're going to start with the simplest one. And we are going to start with this one right here. And we know that this has a diameter symbol and it says 0.391. So we know that's a 391 diameter hole. And for the purposes of this discussion, we're not going to deal with tolerances. We'll just assume there's a block tolerance of plus or minus 10 thousandths. After the 391 diameter callout, we see a symbol that we haven't encountered before, and that's right here. Okay? This symbol simply means depth. So what this is saying is that we have a 391 diameter hole, and it's 1 inch deep. So that means it's not a through hole, where before we saw the word through afterwards. So we're going to jump down to a section view of this block that contains the hole. Remember from our video on section views, right? We're slicing this block in half, looking in this direction. And we see a section view that looks like this. And down here we've dimensioned this hole again. So here's our 391 diameter, right? And here's our 1 inch depth. Okay, and in the section view we can see this hole, and it's not a through hole. It doesn't pass all the way through the block. It's blind, or it has a depth. Now you'll see what looks to be a drill point. Okay, a standard drill, or a twist drill as it's called, looks like this. Has a point on it, right? And it typically has flutes, right? It has this point on it, and that point, they can vary. The common one is that point is 118 degrees. There's sometimes 130 degrees, and nowadays various high performance drills can have different point shapes. But if it's not specified on the drawing, the drill point is assumed to be negligible, and the dimension for the depth of the hole is assumed to be to the full diameter of the hole. So to right here, that's where the depth goes. The drill point is excess depth of the hole, and it's not a full hole, beyond that depth. So in this case, if our two-place decimal had a tolerance of plus or minus 20 thousandths, this hole would have a full depth anywhere from 1 inch, 0.20 maximum, to 0.980 minimum, right? That's if this was a plus or minus 20 thousandths block tolerance on there. Okay, so drilled hole, the depth is to the full depth. So that's 391 diameter, 1 inch deep. And that was this call out. right here. Okay. Now the next one we're going to look at also has a diameter of 391, only this time it's through, right? And then we see this depth symbol that we've already learned about, but there's another symbol over here. And what is that? Well, this, right, we've said this was depth. This means counterbore. Right? And the counterbore is going to be 625 diameter by 0.38 deep. Okay? And if you don't know what a counterbore is, it is, you can see two circles here. The outer circle is 625 diameter. The inner circle is the 391 diameter through hole. And if we look down here in our section view, here's our counterbore. Okay? That's this 625 diameter, right? That's the counterbore, and it's 3/8 deep. Okay? And then this is the 391 through hole here, right? Coming all the way through the block. So counterbore is to recess the head of a screw. Right? So I'll go ahead and just draw it in there. If you're not familiar with this, if this was the head of a screw, you counterbore it so that you can put the head of the screw, right, beneath the surface. Okay? So that's a counterbored hole. 391 diameter through hole, counterbore to a diameter of 625, 3/8 deep, or 0.38 deep. Okay? And the last hole type we're going to look at is the countersunk hole. And that's this symbol here. Right? That means countersink. Okay? Now this call out we see a diameter of 0.406 through, and then we see this countersink symbol and another diameter 0.781 by 82 degrees. Okay, so what does that mean? Well, that means we have our 406 diameter hole through, right? Then we have this feature here, that's the countersink. And the 82 degrees is included. Right? And by included we mean if this is the center line, this was 41 degrees on this side, 41 degrees on this side, and the total is 82 degrees. Right? So we call that 82 degrees, we call included. Right? Because it's both sides of the center line. If the half angle would be 41 degrees. The included angle is 82 degrees. So when we talk about countersink angles, we're talking about the included angle. Now, the 781 diameter is this diameter right here to the edge of where that countersink angle breaks through the top surface here. Right? Okay? So, it's a 406 diameter through hole, countersunk, 781 diameter by 82 degrees. Okay? And that's what we saw up here. 406 diameter through, countersunk 781 by 82 degrees. And that is used for a flathead screw, which most of you are probably familiar with, but that's for a flathead screw. And those are screws that The head looks like this, right? And they could have a slot in them, or they could have a hex socket, but the head has this 82-degree angle on it, and then the threaded shank of the screw is like this, right? That head, that 82-degree head, fits right in here. Okay, so that's for sometimes called a flush head screw. That's so again we can sink that flat head down into our part so that it'll be flush after it's assembled. Okay, so we've got drilled holes, counterbore holes, countersunk holes, and real quick we're just going to mention some alternative callouts. Sometimes a counterbore hole will read same thing, 0.3, what was our size? I'll use the same size, 391, right? Yeah, 391 through. So sometimes it'll read 0.391 through. It's going to be all capital letters. And then they will sometimes say C-bore, which stands for counterbore, 0.625, and they'll actually write out 0.38 deep, or they may abbreviate it to 0.38 DP, something like that. Okay, again, this is an older style, and it is generally best practice today to call it out this way and to use these symbols. These symbols are also described in ANSI Y14.5, which is where, if you remember, that's where we got our definitions for geometric dimensioning and tolerancing symbols. Okay, same thing with the countersunk hole, right? That was 406 through 781. So sometimes that'll be called out 0.406 through. C sink, which is countersink, diameter 781. By 82 degrees. Okay, so this is just a longhand way of doing this. Again, that's typically the older drawings. You're going to see that. Just mention with countersinks, the common angles are 82 degrees for industrial, and you'll see 100 degrees for most aerospace applications. Okay, and all that means is that your included angle is wider, and that's because in aerospace they're trying to get more surface area under the head, and often also putting these fasteners in thinner materials, right? So the thickness of that head tends to be a little thinner because they're flushing these into thinner materials. Okay, so we've got the countersunk hole, the counterbore hole, and the drilled hole. And those are typical hole features that you will see on most drawings.